Assalamu alaikum wa rahmatullah. Today we are going to look at a topic called dimension. From the definition, we say dimension is a way of measuring physical quantities. And this dimension, there are two categories of ways we follow to solve cases of this dimension. Case number one, any given quantity that has a formula, we first write the formula and substitute the dimension values. Secondly, a formula might be given and we were asked to prove whether the formula is right or wrong. Let me start with the quantities that has a formula. For instance, if we were asked to find the dimension of velocity, we are asked to find the dimension of velocity. We first write the formula of velocity. From the definition, it says velocity is the rate of change of displacement with time. Then we say velocity is the rate of change of what? Displacement all over time. After writing this, then we go straight to find the parameters of dimension. There are three things we use in finding the dimension. We have length, which is capital L. We have mass, capital M. And we have time, represented by capital T. These three parameters are the ones we use whenever we wanted to solve dimension problem. For this case of velocity, we say velocity is the rate of change of displacement with time. Then we substitute the values of dimension. Displacement, that means a distance, displacement, length, breadth, and height are all under capital L divided by time, capital T. So our V is equals to LT raised to the power of minus 1. Definitely, the dimension of velocity is LT raised to the power of minus 1. And for acceleration, we still see the formula of acceleration. From the formula, it says acceleration is the rate of change of velocity with time. That means the formula of finding acceleration is equals to velocity all over time. Then we say A is equals to B all over T. A equals to, we already know the dimension of velocity. If we didn't know the dimension of velocity, we must find the dimension of that velocity, which is LT raised to the power of minus 1 divided by T for that T. Then our dimension of acceleration is LT raised to the power of minus 2. That means the dimension of acceleration is LT raised to the power of minus 2. Likewise for force, we know a formula of finding force is mass times acceleration. Mass times acceleration, F equals to ma. For us to find the dimension of force, we say F equals to, what is the dimension of mass? We already say for mass we have capital M multiplied by acceleration. Dimension of acceleration is LT raised to the power of minus 2. That means our F is equals to MLT raised to the power of minus 2. Definitely, the dimension of that force is equals to MLT raised to the power of minus 2. Now, we have seen a way to find the dimension of a given quantity that has a formula. We first write the formula, we substitute the values of that dimension. Now we wanted to prove whether the formula is right or wrong through dimension. If we were asked, for instance, to prove the formula B equals to U plus 80, we first understand each and every parameter there in the formula. We know for B is represent final velocity, likewise U represent initial velocity, A represent acceleration, and small t represent time. So the dimension of B is LT raised to the power of minus 1, that is for velocity. Likewise, U is the same thing as B. Why? Because it's all velocity. The only difference is this one is initial velocity and the other one is final velocity. That means the dimension of U is LT raised to the power of minus 1, like that of final velocity. Then for acceleration, we already know the dimension of acceleration is LT raised to the power of minus 2, and for small t, the dimension is capital T. Then we substitute it back to the formula. The formula says B equals to U plus 80. The dimension of B is LT raised to the power of minus 1 equals to LT raised to the power of minus 1 plus A, which is acceleration, that is L2, LT raised to the power of minus 2 multiplied by T, capital T, that is the value. If you look at this substitution, it's still the same as the formula. Why? Because LT raised to the power of minus 1 represents final velocity, LT raised to the power of minus 1 represents initial velocity, plus is there for A acceleration, dimension of acceleration, it says LT raised to the power of minus 2. Between A and T there is multiplication, and for small t is capital T. That means for simple simplification, Simplify, we have LT raised to the power of minus 1 equals to LT raised to the power of minus 1 plus LT raised to the power of minus 2 multiplied by T. According to the law of indices, if base are the same, for multiplication, we what? We add the power. Then minus 2 plus 1. Why? Because this capital T represents, there is 1 under it, is only didn't show. Then we say minus 2 minus 1 will give us LT raised to the power of minus 1. Then we say LT raised to the power of minus 1 equals to LT raised to the power of minus 1 plus LT raised to the power of minus 1. It means we have 2LT raised to the power of minus 1. According to the dimension formula law says the dimension of any constant number is 1. That means the dimension of 2 is 1. Then we have L2 raised to the power of minus 1 equals to L2 raised to the power of minus 1. Then we say left hand side equals to right hand side. Then it is proved. We know this formula is proved already. Why? Because it is a Newton laws of motion. That is the first motion of Newton equation of motion, say B equals to U plus 80. Second equation of motion, say S equals to UT plus a half 80 square. Third equation of motion says B square equals to U square plus 2AS. So now we have proved the first formula that says B equals to U plus 80. Then I ask you to try S equals to U, UT plus a half 80 square, or B square equals to U square plus 2AS. Then we meet on the comment. Thank you.